Okay. Uh, so in today's class, we are going to learn about psychrometry. What is psychrometry? It's a branch of science which deals with study of mixture of dry air and water vapor. Okay, atmospheric air is a mixture of so many gases, okay, that comes as a dry air, and as well as it also contains water vapor, right? Okay, this subject forms the basis for calculation of air conditioning loads, heat transmission through structures, cooling towers, etc. Okay, they're all based on this concept. You should know what are the terms which are used in psychrometry. First one, dry air. Dry air is a air which does not contain any moisture or it does not contain water vapor. That is dry air. Okay, for example, so atmospheric air is a mixture of dry air and water vapor. Dry air here it means oxygen, nitrogen, carbon dioxide, argon, okay, some of these gases. There is dry air. So dry air is the air which does not contain water vapor or moisture in the air is known as dry air. Moist air is nothing but it is a uh, nothing but dry air plus water vapor is known as moist. Atmospheric air is a moist air, which is a mixture of dry air plus water vapor. This is known as moist air. Next one, saturated air is the air which contains maximum amount of moisture that air can hold for a given pressure and temperature. Okay, so saturated air is the air which contains maximum amount of moisture. Okay, whereas unsaturated air, okay, is a air which does not contain maximum amount of moisture for a given pressure and temperature, or normal atmospheric air is a unsaturated air because it does not contain the maximum amount of water vapor. The next definition, specific humidity, also known as humidity ratio omega, is nothing but defined as a ratio of mass of water vapor to the mass of dry air. Okay, the unit will be kg per kg of dry air. Once again, specific humidity is nothing but the ratio of mass of water vapor to mass of dry air or kg per kg of dry air. Okay, next definition, absolute humidity, also known as vapor density, rho v. Rho v is defined as a ratio of mass of water vapor per unit volume of dry air. Okay, here suffix v represents water vapor and suffix a represents dry air. Okay, remember, even for a specific humidity also the suffix v represents water vapor, suffix a represents dry air. And next we'll go to the next definition. Degree of saturation, it is represented by the symbol mu. It is defined as a ratio of specific humidity of unsaturated air to the specific humidity of saturated air. Okay, both the airs are at same pressure and temperature. Okay, so specific humidity of unsaturated air to specific humidity of saturated air, okay, both at same pressure and temperature. Next, relative humidity, also known as phi. Okay, so it is represented by the symbol phi. It is defined as a ratio of mass of water vapor in the unsaturated air to the mass of water vapor in the saturated air. Okay, both are at same temperature. Both are at same temperature. That is, unsaturated air and saturated both are at same temperature. Also, relative humidity is defined as partial pressure of water vapor in the unsaturated air to partial pressure of saturated water vapor. Okay, saturated means what? It contains maximum amount of moisture it can hold. Okay, at a given temperature. Okay, right. Next, dry bulb temperature. It is represented by the symbol T suffix D. Small t d represents dry bulb temperature. It is a temperature recorded by the ordinary thermometer where its bulb is not affected by the moisture which is present in the air. It's a temperature recorded by the ordinary thermometer where its bulb is not affected by the moisture present in the air. Whereas wet bulb temperature is represented by the T suffix W. It is a temperature recorded by the thermometer where the bulb will be covered with wet cloth and it will be exposed to the movement of air. Okay, so the corresponding temperature which is measured with a bulb covered with cotton wick or wear, okay, is known as wet bulb temperature. Next one, dew point temperature. It is represented by symbol T suffix dP. Here dP represents dew point. T stands for temperature. It is a temperature recorded by the thermometer when the atmospheric air begins to condense. Okay, when it begins to condense, corresponding temperature is measured is known as dew point temperature. Wet bulb depression in okay, next definition. Wet bulb depression. It is nothing but the difference between dry bulb temperature and wet bulb temperature is known as wet bulb depression. The last one, dew point depression, is nothing but the difference between dry bulb temperature and dew point temperature is known as dew point depression. Okay. Go to the next slide. Okay, important psychometric relations. First one, Dalton's law of partial pressure. Already you have come across. It is given by what is Dalton's law of partial pressure? Is nothing but the total pressure of the gas will be sum of partial pressure of the individual gases. Okay, where all the gases and as well as mixture of gases will be having same volume and same temperature. So here suppose I have taken three gases, okay, A, B, C. So total pressure is nothing but partial pressure of gas A plus partial pressure of gas B plus partial pressure of gas C. Okay, you know that atmospheric air is a mixture of dry air plus water vapor. So what is the total pressure is nothing but dry air is represented by suffix A, I told you, and water vapor is represented by suffix V. It is PA plus PV. Here I have written PB, okay, because the atmospheric air is measured with an instrument known as barometer, okay, sometimes also known as barometric pressure. That is why it is I have represented by P suffix B. Okay, that is actually nothing but the total pressure of the atmosphere is nothing but summation of partial pressure of dry air plus partial pressure of water vapor. Next, specific humidity. Okay, we'll derive an equation. Okay, specific humidity or humidity ratio. Do you know that it is given by mass of water vapor to the mass of dry air? It is nothing but kg per kg of dry air. Okay, let pressure, volume, mass R represents characteristic temperature. Okay, all suffix A, okay, represents, okay, pressure, volume, mass, gas constant and temperature for that is for dry air. I have told you suffix A represents dry air. Similarly, pressure, volume, mass, gas constant, temperature suffix V represents for water vapor. Pressure, volume, mass, gas constant and temperature respectively, that is for water vapor. Now we will assume that the water vapor and dry air behaves as ideal gas. Once you know ideal gas, okay, you can apply the equation PV is equal to MRT. So I have applied the equation PV is equal to MRT for dry air as well as for water vapor. I told you air represents suffix air is for dry air, suffix V is represents for water vapor. PAVA is equal to MERATA, that is for dry air. VV is equal to MVRVTV is for water vapor. I have taken the ratios of these two equations. Okay, PVVV by PAVA is equal to MVRVTV. that is this for water vapor, divided by mass R into temperature, that is for dry air. But according to Dalton's law of partial pressure, okay, volume of individual gas is that is volume of the gas, okay, that is for volume of the dry air is also equal to volume of the water vapor, as well as temperature also remains same, that is temperature of dry air is equal to temperature of water vapor. So in the atmospheric air is nothing but what, dry air and water vapor. So the volume is same, that is for dry air as well as for water vapor, and as well as temperature also will remain same, that is for dry air as well as for water vapor. Dry air here means it's a mixture of so many gases like oxygen, nitrogen, okay, carbon dioxide, argon, neon, etc. Okay, so the whether it is a water vapor will be mixed with the dry air, okay, and the temperature also remains same. When you apply the Dalton's law, okay, what happens here, volume gets cancels and temperature gets cancels. Here VV, VA gets cancels, TV, TA gets cancels. What is remaining? So it is PV by PA, left hand side PV by PA is equal to MV RV by MA RA. Okay, TV, TA as cancels. Now MV by MA is equal to, I have simplified what is MV by MA. What is MV by MA? It is nothing but PV into RA. If it go to the left hand side, it will be goes to the numerator, PV RA by PA RV. That will be MV by MA. Okay. I have obtained the equation in terms of mass of water vapor by mass of dry air. So that this MV by MA is equal to omega. Understood? So here PV RA by PA RV is there. You know what is RA? 0.287 for, that is for dry air, whereas for RV is nothing but 0.461 kilojoules per kg Kelvin for water vapor. Okay, you have to remember these values, RA and RV. RA you know is a standard value, and RV, okay, you have to remember. Okay, just put it in the equation for RA and RV and simplify. You are going to get MV by MA. I have written as it is. Okay, RA by RV it will become 0.287 PV by 0.461 PA. Mass of water vapor by mass of dry air is nothing but what? Omega. Specific humidity is equal to 0.62, that is 0.287 by 0.461. If you simplify, you are going to get 0.622 PV by PA barute. What is PA? Okay, here we have written what is PA. It is nothing but PB minus PV. So partial pressure of dry air is nothing but barometric pressure minus partial pressure of water. That is what I have written, PB minus PV. Okay, this is a omega equation for unsaturated air. Okay, when the air is saturated, then the partial pressure of water vapor will be PS. Okay, instead of PV, I have to write PS. Here I should have written omega S. S suffix S is missing here. Okay, this is actually omega S will be 0.622 PS by PB minus PS. Okay, that represents specific humidity of a saturated air. Saturated air means what? The air which contains maximum amount of moisture it can hold for a given pressure and temperature. Okay, here this is the omega represents specific humidity of unsaturated air. That is a normal atmospheric air is a unsaturated air, which does not contain maximum amount of moist or water vapor. That is omega. Okay, so here these equations you have to remember. Vapor density rho v is given by equation omega into PB minus PV by RATD. Here omega is nothing but specific humidity. PB represents barometric pressure in Newton per meter square. Okay, I will written the units also. You have to substitute in these units only. PV partial pressure of water vapor in Newton per meter square. RA is nothing but characteristic gas constant of air. This you know. Okay, TD represents dry bulb temperature in Kelvin. Okay, so when you substitute in this, you are going to get what is vapor density rho v. You have to remember these equations. Next, pressure of water vapor, okay, you are going to find using Carrier's equation. So the partial pressure of water vapor is given by PV is equal to PW minus PB minus PW, TD minus TW, 154 minus 1.44 TW, where PW, P suffix W represents what saturation pressure corresponding to wet bulb temperature. Here W stands for wet bulb temperature, partial, okay, pressure, saturation pressure corresponding to wet bulb. Okay, you know the wet bulb temperature, go to the steam tables. For that wet bulb temperature, what is the saturation pressure? You have to find it out from the steam tables. Next, PB, barometric pressure or atmospheric pressure in bar. Okay, this you have to substitute in bar only. This equation has been done in such a way that you have to substitute in bar only, both PB and PW. Next, TD is dry bulb temperature, you have to substitute in Celsius, and TW is a wet bulb temperature, that is also in Celsius. Okay. See here, in the denominator they have given 1.44 TW is there. You have to substitute the value in Celsius only. Okay. Enthalpy of moist air. Okay, next equation. It is given by H is equal to 1.022 dry bulb temperature plus omega specific humidity HFG. Okay, this HFG, okay, you are going to find at dew point temperature. Okay, what is a dew point temperature? Okay, you will be knowing, and you have to go to the steam tables for that temperature. What is HFG? You have to find from the steam tables plus 2.31 TDP. Okay, that is dew point temperature. Here TD, you know, dry bulb temperature, omega specific humidity, and dew point temperature. Okay, here also TD and TDP both you have to substitute in Celsius only. The equations is modified in such a way that you have to substitute in Celsius. Right. Next, HFG, I have told you latent heat corresponding to dew point temperature. Okay, yeah, dew point temperature you will be knowing, and you have to go to the steam tables. From according to that dew point temperature, what is the HFG you have to find. Okay, next we will go to the numericals. Okay, the pressure and temperature of mixture of dry air and water vapor are 0.9819 bar and 21 degrees Celsius. The dew point temperature of the mixture is 15 degrees Celsius. Find the following: partial pressure of water vapor, relative humidity, specific humidity, enthalpy, specific volume. Okay. First, they have given pressure and temperature of a mixture of dry air and water vapor. Okay, that is a, you know, normal air is a mixture of dry air and water vapor. That is a barometric pressure they have given 0.9819 bar. Okay, and okay, whenever they say that the temperature of the mixture, it will be dry bulb temperature only. Suppose if there is a wet bulb temperature or dew point temperature, they will specify. If they have not specified, it means it's at a dry bulb temperature only. So TD will be 21 degrees Celsius, and dew point temperature, see they have given TDP 15 degrees Celsius. Okay, now from steam tables, to go to the steam tables at 21 degrees Celsius, what is the saturation pressure? Okay, that is what you have to find. PS. Okay, that will be 0.02485 bar. Okay, so you should remember here TD corresponds to PS. Okay, pressure, saturation pressure ಎಷ್ಟಿದೆ ಅದು ತಗೋಬೇಕು. Next TDP, okay, dew point temperature 15 degrees Celsius. Okay, that corresponds to PV. It will be 0.017 bar. Okay, at 15 degrees Celsius you have to find what is the pressure from the steam tables. That will be PV. Okay, here you have to remember TD corresponds to PS, TDP corresponds to PV. If you know wet bulb temperature, then TW will be PW, equal to PW. This you should know. Once you got PV and PS, you can find phi, no? So ಇಲ್ಲಿ partial pressure of water vapor in the mixture, okay, partial pressure of water vapor, okay, that is what we have found, PV, partial pressure of water vapor is PV 0.017. This is the first one they have asked. Next you have to find the relative humidity, PV by PS 0.017 by 0.0 multiplied by 100, you are going to get 68.27 percentage. Okay, next omega is nothing but 0.622 PV by PV minus PV. Okay, so omega, it is nothing but specific humidity they have asked. No, in the third one is a specific humidity. PV you have found, PB they have given in the problem. Okay, just substitute and get the value of omega. The PV will find out ಮಾಡಿದಿರಲ್ಲ from steam tables 0.017. ಓಕೆ, ಇದೆ ಇಲ್ಲಿ ನೋಡಿ, ಇಲ್ಲಿ ಬಾರಲ್ಲೇ ಹಾಕಿದೀವಿ. ಯಾಕೆ ಅಂತಂದ್ರೆ ಈ ನ್ಯೂಟನ್ ಪರ್ ಮೀಟರ್ ಸ್ಕ್ವೇರ್ ಮಾಡಿದ್ರು ಇಂಟು 10⁵, ಇಲ್ಲಿ ಕೆಳಗಡೆನು 10⁵, 10⁵, 10⁵ gets cancels. So the unit will be kg per kg of dry air. Mass of water vapor by mass of dry air is nothing but kg by kg of dry air. We have to write down the units also. Next, enthalpy, you know the formula. Okay, and dew point temperature ಕೊಟ್ಟಿದಾರಲ್ವಾ ಅವರು, ಎಷ್ಟು ಕೊಟ್ಟಿದ್ದಾರೆ, dew point temperature 15 degrees Celsius. Okay, at 15 degrees Celsius you have to find what is HFG, latent heat. You have to go to the steam tables at 15 degrees Celsius. What is the HFG value you have to find, and this you know dry bulb temperature they have given, omega you have found just now 0.01096 plus 2.31 into TDP, that is 15. Okay, you are going to get 48.87 kilojoules per kg of dry air. And next, last one, specific volume of the mixture. Okay, so VA is nothing but RATD by PA, or PV is equal to RT, you know, or V is nothing but RATD by PA. So RA is nothing but 287. It is in joules per kg Kelvin. 287 is joules per kg Kelvin. Dry bulb temperature they have converted into Kelvin by adding 273, and the pressure of dry air is nothing but PB minus PV. PB you know 0.9819 minus PV is nothing but 0.017 into 10⁵. Just simplify, you are going to get this 0.8744 meter cube per kg of dry air. Understood how to find? Next, we will go to the MCQ, multiple choice question. First one, the ratio of partial pressure of water vapor in the mixture to saturation pressure of water vapor is nothing but what? Relative humidity. That is option D is the correct answer. PV by PS is nothing but relative humidity. What is the relative humidity for saturated air? Okay, it's nothing but 100%, because PV will be equal to PS. PS by PS will be 1. 1 multiplied by 100 in terms of percentage, it will be 100%. Okay, with this, okay, you are equipped with various thermodynamic relations and its applications to ideal gas mixture. So you are able to find thermodynamic properties, and you are able to identify the different relations of thermodynamics and also applicable to ideal gas mixtures. This is the learning outcome of it. So in today's class, what you are all learnt about the different terms which are used in psychrometry, and you studied the important relations like Dalton's already have come across, obtained the equations for specific humidity, and also equations like vapor density, enthalpy of moist air, pressure of water vapor. Okay, you have to remember these equations, you have to by heart. Okay, thank you.